Assalamualaikum. My name is Muhammad Ashraf bin Kamaruzaman, TB22010. Today, I'm going to talk about two important types of sensor used in industrial and engineering application. My lecturer name is Razali bin Dawood. Okay. Okay. In this presentation, I will explain how each sensor works when they are used, their strength and weakness, and how to choose the right one for a specific application. Okay, let's begin with functionality. Okay, for a resistive sensor, which is also called a conductive or resistant types level sensor, works by measuring the changes in electrical resistance when a conductive liquid touches the sensor probe. The principle is simple. As the liquid rises or falls, it makes contact with a different point on a resistivity path, changing the resistive value. This change is important as a change in liquid level. However, this only works if the liquid is electrically conductive, such as water, acid, or other electrolytes. Okay, for a capacitive sensor, it operates a different principle. It measures the changes in a capacitor that occur when a material, either liquid or solids, come close or fill space between two electrodes. As the material level changes, the dielectric constant of the medium between the electrodes also change, altering the capacitance. And this change is then converted into a level reading. This method is more reliable and more flexible because it doesn't require the material to be conductive. Capacitive sensor can detect non-conductive material like oil, plastic, pellet, or grain, making them more versatile. Okay, now we're gonna move for the applications. For the first one is a resistive sensor. Is commonly used in water tanks, battery electrolytes, level monitoring, automotive fuel level detection, a simple chemical tank as long as the fluid is conductive. Their low cost and straightforward design make them ideal for environments where conditions are stable and the liquid is clean and conductive. On the other hand, for the capacitive sensor are used in a much wider range of applications, such as oil tanks, food processing and beverage storage, pharmaceutical industries, grain silos, plastic and powder processing, and wastewater treatment plants. They are especially valuable in situations where the material is non-conductive or where non-contact measurement is preferred, such as in a hygienic or hazardous environment. Okay, next I will talk about the accuracy. As we know, accuracy and sensitivity are crucial for many industries. For the resistive sensor, generally provide moderate accuracy, typically within plus minus 3 to 5%. For basic application, this is sufficient. However, they can become less accurate over time due to corrosions, scaling, or temperature changes affecting the resistance. Their sensitivity is also relatively low. They may not respond well to small or rapid changes in level, especially if the material is foamy, sticky, or a foam deposit. For the capacitive sensor, it's offer high accuracy, often within plus minus 0.5 to 2%, because they can detect very small changes in dielectric properties. They are highly sensitive to even minor level fluctuations. This is ideal for application that require precise control, such as pharmaceutical mixing tanks or microdosing system. However, capacitive sensor can be influenced by a changes in temperature, humidity, or the dielectric constant of the material, which can affect calibration. Still, modern sensors are often designed with compensation features to handle these challenges. Okay, where when it comes to measurement range, the difference are clear. First, for the resistive sensor, we are limited by their physical design. Most are designs for a short range measurement, such as a small tanks or container, typically a few centimeters to a few meters. Okay, for a capacitive sensor, however, are much more flexible. They can be configured by for very small measurement down to a few millimeters, or scale up for a large silos and tanks that are several meter tall. This broad range makes a capacitive sensor suitable for a wide variety of industrial process, from fine dosing to a bulk storage. Okay, we're gonna we're gonna talk about maintenance and cost. Uh, Relative sensors usually require a direct contact with liquid, which can lead to visual light, uh, corrosion, scaling, sensor falling. This means they are often required regular cleaning and inspection, especially if the liquid is chemically aggressive or a level leaf residues. For the capacitive sensor, in many cases, can be installed outside the tank wall, especially if the tank is made of a plastic or another non-metallic material. This allows for non-contact measurement, which is cleaner, safer, and easier to maintain. Even when installed inside the tank, capacitive sensor have no moving parts. It's reducing the risk of a mechanical failure. This leads to a longer lifespan and a lower maintenance cost over time. Okay, next is a cost, which is always a factor in our decisions. Resistive sensors are generally cheaper to purchase and install. This make them ideal for application where budget is limited and high accuracy is not essential. But for the capacitive sensor, it's a more expensive upfront due to their advanced electronic and versatility. However, their durability, reliability, and low maintenance often result in a long-term cost saving, especially in industrial environment. So, while the initial investment is higher, the return of investment can be significant in more demanding application. Okay, for the conclusion, these sensors are more simple, uh, cost effective, and suitable for a basic low precision task involving conductive liquid. For the capacitive sensor, is accurate, sensitive, and highly versatile. It able to measure both conductive and non-conductive material, including solids and liquids. In terms of installation and maintenance, capacitive sensors are generally easier to manage and last longer. Okay, for when deciding the sensor to use, it is important to consider not just the material but also the environment, required precision, and a long-term maintenance needs. So, in conclusion, there is no one size fits all solution. Choosing between a resistive and a consistency depends on the specific application requirement. Understanding the strength and limitation of each level of each type allow us to make informed, efficient, and cost-effective decision in designing a level measurement system. And I think that's all from my presentation today. Thank you.